Well, hey, let's take a look at something else here for a little bit. Be sure to get your questions into us, guys. Send any questions related to what Craig's just covered, or else, actually I'm going to cover a quick piece of equipment here right now from Heidenhain. And if you have any questions related to that, go ahead and shoot it to me at techno-live@qualitydigest.com. Okay, so Heidenhain, as we mentioned at the top of the show, is our sponsor today. Heidenhain manufactures a large number of digital readouts and in-process gauging tools and so forth, and they sent us one of their tools. This is called the Gage-Chek. This is essentially a digital readout. If any of you have ever worked with check fixtures, you know that maybe a typical setup might be you have your check fixture and maybe you have a number of dial travel gauges installed in that check fixture, and you take your part, you put it in the check fixture, and maybe you have 3 or 4 gauges in that fixture. So you got to go around, you got to read and note down each gauge, what the value was, is it in tolerance, is it out of tolerance. Maybe you have to do some gauge math. Maybe the measurement is related to 2 gauge measurements. All of that. It's a very manual operation, a little time consuming, also prone to error. So Gage-Chek, the Gage-Chek product is really what addresses this. This accepts, this particular model, this is the ND2100G, accepts up to 8 gauge inputs. We happen to have 2 gauges with us today. These are linear measurement gauges from Heidenhain. And I'll show you just kind of run you through real quick what this does. This happens to be an ACANTO gauge. This has got a 2 micron accuracy over the full travel of the gauge, which is, I believe this one is 25 millimeters. And let's take a look at the Gage-Chek here. So right now, get my finger in the way here. There we go. That's the easiest way. There we go. So okay. So as I'm moving the linear gauge, the digital readout is, you see, it's reflecting the travel there. So that's one way of looking at data. We can also go to, let's say, a vertical or horizontal bar display. So this happens to be the vertical bar display. Now notice as I'm moving this, it starts off green, turns yellow, then turns red. So obviously I can program in tolerances for each gauge. So that means that each gauge becomes its own go, no-go gauge. So you can very quickly, if you had multiple gauges, you'd be seeing multiple bars. You could very quickly do a go, no-go check on all of your gauges. We can also look at this as a dial, kind of an analog dial gauge. Notice we've got the digital readout on the bottom and an analog type gauge. Oops, sorry, wrong gauge. There we go.
Ooh, dial fan.
There we go. So you've got an analog type gauge on top. Also notice that it has the tolerances programmed in, so green, yellow, red. And also you have your digital readout on the bottom. Now the thing that makes this type of product really super useful is, like I said, is the ability to do gauge math. So you can do calculations based on readings from multiple gauges, or you can do calculations based on the reading from a single gauge. And I'll show you how simple it is maybe to set up to do run out. So we would come over here. I would go into my menu, and we'll go into setup. I'm going to scroll down here to formulas. So I'm going to create a formula for my A measurement. I'm going to delete what I already have in there. And let's program in. First thing I'm going to do is I'm going to say find my maximum measurement. This is dynamic, so it's looking for the maximum dimension, maximum value from the gauge continuously. And I want to look at my channel 1 gauge. And I'm going to subtract from that the minimum value that it finds on that same gauge. So now my formula essentially is my maximum value that I find minus my minimum value that I find. That is going to be my run out. So now I can simply go back to my display, and we're looking at A. And I've got a little test fixture here. You can see I've got here's my linear measurement gauge right here. I've got a little cam on the bottom. So as I rotate this, you can see the gauge move up and down. And if you look at the value, you can see my value is slowly increasing as it finds the maximum difference between the high value and the low value. So obviously once I've rotated through 360 degrees, I have simulated my run out there. So now I'll simply store that value, and we'll zero it, And we can take another measurement. We'll do the same thing again. So here again, I'm just simply rotating 360 degrees. It is calculating for me, on the formula I put in there, what my run out is. So now I can enter that value. And now let's say, now we want to go take a look at the values that we've stored and maybe some other information about them. Go to View. And I can look at an SBC chart. Notice there's already data in here up at the top. My upper control limit, my lower control limit, I've already programmed in. So we got our little SBC chart there. I can look at a histogram of the data. A channel, B channel, that's the B channel. There's the A channel. I can look at the raw data. So here's all the data I collected on the A channel. I can look at the A and the B at the same time, or I can select just the A or the B. Remember, we only have 2 probes plugged in on this. It does accept up to 8. Another thing that we can do, which is really valuable, if we go back to the, oh, actually we can do it here. These ACANTO probes, and I think most of the HEIDENHAIN probes, are smart probes. In other words, there's a chip in there that contains all the information related to the type of probe, the interface, the serial number, so on and so forth. And we can take a look at that very quickly. So I'll go back into my menu. We'll go to Setup again. And I'll scroll down. By the way, any of you who have used a Quality251 or any other HEIDENHAIN or Medtronic readout will recognize the menu structure. Craig tells me it hasn't changed in about 1 million years.
About 1983.
Exactly. So okay, here's our channels. So notice up at top, it's telling me what channel I'm currently on. That's C1. If I click on Info, it tells me everything about this probe. It tells me the ID number, the serial number, the name of the probe. This happens to be an AT3018, ACANTO probe.
You can look at the accuracy of the probe, can't
And
you?
You can look at...
It was in there somewhere.
That might be somewhere else. The length of the probe is, this is a 30 millimeter probe. Okay. Step size, 23 nanometers. We can go to diagnostics. The diagnostics will tell me the signal quality for both the absolute encoder and the incremental encoder. And it's telling me that both of these are way into the green. So this probe is fine in terms of signal quality. And we can also look at errors. There's a number of different error codes that come up or can come up if something is going wrong with the probe. I've got all greens here. Tells me this particular probe is fine. I can increment my way up to another probe, and I could step through all my probes and do diagnostics or look at the air quality on them. So again, this is just a very useful tool, particularly if you're using multiple gauges in a setup, and you want to be able to very quickly be able to do a go no go test, or to be able to do complicated math. Particularly, some of you who have where you might be doing 2 gauges opposed to each other to measure, for instance, thickness. You could do that. And the math for doing that is you just write it all in there. So again, this is the Gage-Chek, the ND2100G from HEIDENHAIN. Thanks HEIDENHAIN for sending that to us.